Hi, I am Moumita Ganguly. Welcome to our YouTube channel Autonomous Academy. So we are going to start a series on laser physics. So today's goals are going to be introduction to laser, what do you mean by it, characteristics of laser and basic comparison with normal light. Since we know that sun is the greatest source of energy on earth, big or small or fractions of radiations emit from the sun that we can see is part of solar spectrum, also known as visible light. We cannot see most of the sun's spectrum, but including invisible radiations, X-rays, infrared radiations, UV radiation, etc. If we talk about visible light, which is also known as normal light, have its own range of wavelength, visible wavelength, which are between 4700 Armstrong to 7800 Armstrong. These different wavelengths of visible light has different strains of colors, which is also known as color bands. Clearly, normal white light is a mixture of 7 different colors, which are violet, indigo, blue, green, orange, yellow, orange, red in sequence. Another feature of normal light is that even though it is moving in one direction, it spreads along all the directions. Normal light does not have the property of unidirectionality. That means it spreads along all the way out. So if we make few changes in normal light, then we will get some of its miraculous properties. Mainly these two are the related to qualities mentioned above. First one is normal light is made up of 7 colors. We have to pick any one color which is of single wavelength. That means single color with single wavelength. And second one is limiting the spreading property of normal light, as you can see on the second picture. Okay. After changing these two properties of normal light, we get a light which is more defined, known as laser, which is nothing but a specific form of normal light. So let's learn about laser in detail. So in this slide you can see in 1960 Theodore Maiman developed first a moving laser, which is ruby laser, a device from which red color laser light was produced. Laser stands for light amplification of stimulated emission of radiation. Since we know that normal light is a source of energy, travels in vacuum about 3 into 10 to the power 8 meter per second. Also, we know that sunlight takes approximately 8 minutes to reach the Earth's surface. So the question arises, what is light? Simply, light is a kind of energy released by an atom. Light is made up of very small particles called photons. Okay, then let's discuss about lasers. So laser is a device itself which is used to produce stimulated atoms to emit light at particular wavelength and amplifies that light through producing narrow beam of radiations. Then the emission covers extremely limited range of visible infrared or UV. UV, that means ultraviolet wavelengths. So lasers are the light beams that are so intense they can travel miles into the sky, and we also know that many of the laser shows are happen. That means many laser shows are playing around the world. And also we know about laser cutting machines, in which lasers are used to cut the acrylic boards in a particular shape or size. Again, laser is a device that emits through a process of optical amplification based on the stimulated emission of electromagnetic radiation. So we will know more about optical amplification and stimulated emission of radiation later in this video or in further videos. So let's get into the characteristics of laser. So laser is one of the greatest technical discovery of 20th century, as it was convinced by Einstein in 1917 when he wrote the quantum theory of radiations. So characteristics of laser covers directionality, monochronicity, coherence and intensity. So we will get to know each and everything one by one. So first, directionality. The ordinary source of light, or we can say a bulb or sun, emit light in all directions. The light emitted by these two separates out considerably as the light propagates through space. The beam divergence of ordinary source in very large and useful for lighting homes and workplaces. As you can see, bulbs in our homes are just have a high angle of divergence, so they can light up the room very brightly. On the other hand, laser beam travels only in one direction. The property of laser that travels in one direction without spreading is known as directionality. The negligible divergence of laser is useful for the range finders and remote sensing, etc. So in today's world, laser is most of the useful thing in our day-to-day life. Okay, as we know, in TV also, you have TV in your homes. In TV also you have a laser light in front of the remote, so you can change the channel and do whatever you wanted to do with the remote. Another characteristic is monochronicity. Monochronicity is a property of light containing only one wavelength or color. No source of light can emit monochromatic light, that is, the light of single wavelength or color. On comparing laser beam by the ordinary light, laser beam has the characteristics of monochronicity, whereas the ordinary or the normal light has wide range of wavelength or frequency. So laser light has a small range of wavelength or frequency, that is a small bandwidth. The bandwidth of an ordinary source of light is about 10 to the power 10 hertz, and the bandwidth of a good laser is 500 hertz. So now coherence. Coherence is another great characteristic of laser. An ordinary source of light emits light in all directions randomly. The light waves emitted by the ordinary source of light spreads in all directions, such beam of light whose component waves are not in phase with each other is known as incoherent beam of light. As you can see in the first figure, the beams are incoherent. That means they are not aligned with each other, and in other hand, in second picture, the waves are aligned to each other, as they are all equally going up and down. So the light waves emitted by the laser are always in phase with each other at every point in the space. Hence laser light beam is known as the coherent beam of light, and it is an important property or characteristic of laser. And the fourth characteristic of laser is intensity. Since an ordinary light spreads in all directions, the intensity reaching the target is very less. But in the case of laser, due to high directionality and coherence, the intensity of laser beam reaching to the target is highly intense. So these are the four characteristics of laser. Now let's just compare laser radiation with a normal light. As you can see in the picture, monochronicity. In lasers we have monochromatic light, but in a normal light we don't have monochromatic light, because monochromatic means only single color, and always only in lasers we can see a single color, whether it will be a green color laser or red color laser or blue color laser. But in light we can see only a white light or a yellow light. So that is the basic difference between them, because the normal light is a mixture of 7 colors, so we cannot see any of the colors. Okay, then second property is coherent, and already mentioned it above that the laser is has coherent waves, and the normal light has incoherent waves, as you can see in the picture, that their phases are unequal in a normal kind of light, and the phases and the waves of the laser light are coherent. And third one is directionality. So the laser has only one direction, but in the left side you can see that the domestic light or a normal light has only brighten up all over the place near it and get unidirectional or undirectional. So this was the third major difference. And now the last one is intensity. So laser has the high intense in nature, but normal light, as you know, in a room we can put a normal light and it will glow in the room, but if you can see it from 5 to 10 kilometers or 10 to 200 meters, you cannot see the light that properly. But in the case of laser, the laser is high in intensity, so you can see it far away. As you know that laser shows, okay, laser shows can go far away to the sky and covers the longest distance that it can cover. And it also depends on the nature of the laser that is producing the laser light, that how intense the laser is, so that it can produce an intense light. So for today, this is it, and thank you for watching this video. In next session we will cover some principles of laser. Thank you.